Okay, we are back, and for a quick update for where we got since last time we left off, I got the scoring algorithm to work. So it's pretty simple. We can look at it real quick. Um, so these are the letters that get a point, letters and then a space. So any of these letters are a space, and it's basically just counting instances of these in a string, um, and adding a point for each one. So we have a few tests around that. We have a test that says that the letter H, base 64 encoded, and then encrypted with two hex A's. The A scores, um, that it finds A, gives a point to A. We also encrypted the word hello and ran the A against it and scored it, and A came out top for it. We see that 8 got 2 points, B got 1 point, but A scored 5. And then I think that's where I left off. But we have the basic algorithm working. So we pass it a hex string. It runs that hex string against all of the hex characters, scores those down here, and yeah. Let's see, do we have anything else? I think that's everything from where I left off. So now we're going to try to score this and see what we get. So we need to write a test for that. So it should score. Oh, and let's just score that and do. We're going to do this. Var scores equals. We'll just steal this one for now because we don't know what our score is going to actually be. And we'll say var Xor entry equals fixed Xor that. Oop, nope. Actually, it's just this. We don't even we already know what our entry is. Var hex string equals this, right? We don't have to. This is already the Zord string, right? This is the hex encoded string that has been Zord against a single character, so we don't have to do it ourselves. And we're going to say single character Zor's hex string must equal to um, scores, right? And it's going to error, but it's going to error usefully because we'll have an entry in our scores for each of these, and it'll tell us what the matching numbers actually are, right? So let's run that. I found a cleaner way to run these tests. Just a second. Sorry about that. She had to show me the picture she drew. Very important. can't argue with that, right? Um, okay, so running our tests. There's our tests. Oh, look, we got scores here. So it looks to me like this is our most likely candidate right here. It's either a, so I bet if we can eyeball it and see, and then this will actually give us an opportunity to improve our algorithm too, because I bet this is going to be some kind of string value, right? So um, we'll write a test C. So let's update our test. So expecting 1, but was expecting B to be 1, but was 0. So it is definitely not B. Expecting 5 to be 0, but was 11. So it could be 5. 5 is possible. I think there's some optimizations we can make to our tests. In fact, I think we need to, well, we'll talk about it, but I think that some of these letters should be worth 2 points and some of them should be worth 1 point or no points. Yeah, just 1 point. So if we go look at, let's go look at letter frequency English. Here we go. Let's go look at this one more time. So we have, these are our most frequent letters. E-T-A-O-N. E-T-A-O-N. So E-T-A-O-N, right? Should be worth like 2 points. And then R I S H D should be worth like 1 point, right? And then I don't think we should be counting the spaces at all. We'll work on it. So let's just tweak our algorithm first. Or let's fix our test first. So we've got 11. You know what? Nope. Let's leave our test alone. Let's tweak our algorithm. So what do we think it probably actually is? So it's going to be one of these three, right? Let's see if we can get one of them to stand out. So let's take the space out entirely. Let's do, um, let's see, what's the best way to do this? So we can map these and then map those, right? Okay, yeah, so let's do this. So filter where these are this, then sum the scores, right? So score string is, so we take all of these characters and then we sum them, right? We could do that, and then we could do the next entry and then sum that, and then yeah, so let's just do 2 points for these. So we're gonna do this. So var 2 point letters equals so E T A O and N. Man, this is very Wordle, right? Like if you've played Wordle like me, you're like, all right, what are the like um my starting Wordle word is arise, A-R-I-S-E, because it has um, R, which is super common, S, which is super common, and three vowels, and it has the three most A, R, and I, which are like three of the most common vowels, right? But actually, this makes me want to change my starting Wordle word to something like, well, it has to be a five-letter word, so I don't know. We'll think about it. I'm gonna think about it though. But it's making me want to switch up my Wordle. So ETAON, and we're gonna do um, bar 1 point letters equals, and we're gonna say R I S H and D. Okay, we're not even gonna include L. We're going to leave it out entirely because it's like the next step down according to Wikipedia. So then what we'll do is we'll say, yeah, so we'll do this. We're gonna sum them twice. So we're gonna do so 2-letter var 2 point scores equals point scores 2-pointer scores. This drives me nuts. I got to get all my indenting the same. Is going to be map. It's going to be this character size of candidates filter entry. Why is that 2 nests deep? That doesn't need to be double nested like that. Entry, filter, entry. There we go. Entry character equals entry. Okay. Filter size of, okay. So, right, because we're only checking it for one character, right? And then var, okay, and then we'll do then scores sum scores times 2. Okay. And then we'll do I guess it doesn't matter. We can just do this. So we'll do we can just do it all here. So we'll just do this. So we'll do var 1 pointer scores equals that. And then we can say 2-pointer scores plus 1-pointer scores. One of them will always be 0, right? Because, no, it won't. So, is that, so we're scoring the string, right? No, Yeah, that's actually good. One of them won't always be 0 because we're counting the 2 pointers, counting the 1 pointers off the string, and then adding that. So this is going to break our tests, but in a good way because we're going to get like hello is going to become worth a lot more points this way. So what's he have? What do they have as their most common here? So ETAOIN SHRDLU. So ETAO, we're going to follow their suggestion. IN. We're not going to follow Wikipedia's suggestion. We're gonna follow theirs. So if we do this SHRDLU. Okay, so these are 2 point letters. These are 1 point letters. Nothing else is worth any points, right? So, okay. So we'll try that. So this is going to break our tests, but it's going to break our tests in ways that makes like hello stand out with a lot of points. Yeah, we're going to see. So all of our scoring is going to break here, but that's okay. We're going to break them in useful ways. Not enough arguments. Function parameter, it should score. What is it saying? Not enough arguments in do must. Single character source must equal to scores. Not enough arguments. One for function with parameters arg1 at 2 pointer scores. 2 pointer scores equals, oh, yeah. So 2 pointer letters map 2 pointer 1 pointer letters map. There we go. Let's see. We're going to do this. Now we're going to keep it the same. I like it the way it is. It goes way out past the 80 character space, but it's okay. Let's keep it the same. So, yep, I think we're good. That should fix that problem. And let's actually run the tests this way. So get clean test output that's easy to read, right? There we go. So let's look at our first test. It should score hex string built from hello as 5. 5, but was 7. Right. Okay. So we can look at why. So it's HELLO. H is worth 1 point. E is worth 2, so that's 3. 4, 5, 6, 7. That's right. It's working. Okay, cool. So the hello becomes worth 7 points. Must equal to, this becomes 7 points, right? And it should score. Okay, so that ought to fix that test. loving the way this is coming together. Because then this should make this one here a lot more robust and easy to understand. So we'll look at it last. So expected hello to be 5 but was 7. Where's our hello? Did I do this wrong? I changed the wrong one. Hello expected root to be 5 but was 7. Score hex string. Where's my test for that? Score hex. Yeah, here we go. Hello must equal to 7. Yep. Score hex string. Hello must equal to 7. Okay, so try that. See if that test is now passing. It should be. Let's look at score hex string just to make sure we've got that right. So score hex string just runs score string over a hex string, which is what we're doing. Yep. Okay, so we've got single character Xors. It should score A to be highest when hello is encoded with that hex character, expecting B to be 1 but was 2, expecting 8 to be 2 but was 4. Okay, so 2 and 4. So B becomes 1 and 8 becomes 4. B becomes 1 and A becomes 4 in, it should score A to be highest. Should score A to be highest. 8 becomes 4. Okay, so it had 2 matches of 2. And B becomes 2. It had 1 match of 2. Right? But A is 7, which stands out drastically among the rest. So that's fine. And it should, okay, expecting 8 to be 4. So that should pass that test now. So, okay. Love it. Love it. We're we're zeroing in on, I think, a working scoring system. So should score A to be highest, B to be 1 but was 2, expecting 8 to be 2 but was 4. Did I scoring A to be highest, expecting B to be 2 but was 4. How did I change that? B to be 2 but was 4. No, B was 2. Yeah, expecting B to be 1 but was 2, right? Score A to be highest. Score A to be highest, expecting. Did I not save my changes? I probably didn't save my changes. That's probably what the issue was. So I'm getting used to the new IDE and what like saves when and what doesn't, right? So, okay, so that test is passing now. It should score A to be highest, right? Okay, and we're going to skip the big one for now. We're going to go to it should score a string with 2 E's as 2. That's wrong. Expecting to be 2 but was 4. It should score a string of hello as 5 but was 7. Okay. So it should score a string of 2 E's as 2. That should become, it should score a string of 2 E's as 4 because we changed what E scores as, right? So, and this should score a string of hello as 7. We changed that. I think that gets us up to all of our tests passing, but the last one, I'm intentionally not looking at the scores on the last one because I want to see, I wanted to be surprised what it thinks is the right answer, because then we're going to write a test that's going to spit out what this actually says, because I'm sure that it's some snarky comment, right? So let's see. So, okay, so 5 is 17 now, and 4 is 15, and 7 is 18, and 1 is 14. Interesting. So this went from 11 to 17. This went from 0 to 18. Because I never set up my numbers, right? So like this is working from the original score. So it's going to be 7 or 5 as likely candidates, right? So interesting. So we'll look at our, so let's just run it. Look at our score here. So 5 should be 17. All right. And A should be 0. So it's definitely not A. Okay. And 4 should be 15. 4 should be 15. So it could be 4. Um, 3 is 1 and 8 is 0. So 3 is 1. So it's probably not that. And 8 is 0. So it's not that. 7 is 18. It is probably 7. 1 is 14. It could be 1. Wonder what happens if I add this. No, no, we're not going to do that. 1 is 14. And then 6 is 6. 6 is 6. Okay, so we've got our scoring system. I think we have passing tests. Let's take the 7, XOR our string, or take our string, XOR it with 7, and see what it spits out. Okay? So we're gonna, okay, we got passing tests. So let's do XOR break. Let's do XOR test. Let's do it in XOR test, all right? It applies a fixed XOR to this. Let's grab it over here so we know we've got the right thing. To that. With key of 8, right? Key of 7? 7. 8 is 0. 7 is our key. Key of 7. So we need to undo. So we need to var hex string equals this, right? And then var secret equals 7, and then we're going to write pad 7 size of hex string with 7, right? Oh, come on. Right pad hex string. So do we need to import right pad? Yeah, we do. Okay. So import right pad from DW core strings. Okay. All right. And then fixed XOR hex string secret must equal to, and we're just going to give it an empty string and see what we get. All right, so let's run this test. and see what it says. It's going to say something, I bet. It applies a fixed string. Expecting to be, but was. Oh, of course, right. So we need to, okay, a couple of things we did wrong. So we want, so this is a hex. We want from hex to string this must equal to, and so we need to import from hex to string from binaries. Yeah. Okay. And we're going to run it. Let's run it from the terminal. I know. I just made a test. I know that it runs all of the tests of the whole suite, but it runs them a lot cleaner, and we get a nice output of what it's. I don't like the look of the test results over here. What's the debug console give me? Yeah, the debug console gives me a useful one. We could run it and look at the debug console, but we can just as easily run it and look at the terminal. Well, that's not going to be right. Okay, so what's our next highest candidate? Because that looks wrong. So why did it have a score of 18? So it had an L, which is 1. It had a D, which is 2. It has an F, A, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I mean, that's 18, right? That's that many characters in that string. So let's try a different one that scored high. Let's see. We also had, so this had 15. Let's clean up our look here. What we got here? What we got here? So we got 18. We got 17. So let's try 5. Let's see what we get. So let's look at 5. So 5. If we do this with 5, all right? Let's try it again. And I forgot to open up my chat, so I don't know if anyone has been chatting. Let me check real quick just to make sure I'm not missing any.
Okay.
W's,
okay.
guys.
You guys.
Missing any dashboard chat stuff. Oh, looks okay. All right. Uh, I mean, that's also a lot of valid characters. Maybe they actually just used. Maybe they didn't actually use something that. Or maybe. Zord against a single character. Find the key, decrypt the message. Maybe. No, that's still going to be the same. So, okay, so that's the score for that one. That looks like a good, I mean, that's a pretty dang good secret if you ask me, if that's what they're using. Um, we'll try 4 and then we'll try 1. And if anyone, let's try 4. Oops. If I don't get a message, I'm going to start Googling like what people think they're at, like what that string. Let me look at this string. So if I hex, let's look at this. So new set. So import star from binaries from hex. Okay, so it's a bunch of gibberish before it's sword. And that's also a bunch of gibberish. Curious. Curiouser and curiouser. Maybe they didn't give me a message. 4. And then the last one we're going to try is 1. Right? 1. And then while we're doing that, I'm going to grab this and throw it into Google because I bet it's something you can Google. Scoring operation. Characters, for encoding. Okay. Okay, so it's because. All right, let's look at this. So I'm doing something wrong. So before encoding, it's this, right? After encoding, it's this, right? Scoring is basically comparing the output to what you expect the output. So how to write. So I have input, repeat A and ASCII by length. Input, repeat, it's going to be output, edit. Seems a very long time to pass. I implemented a solution in Python. Successful line. Cooking MCs like a pound of bacon. Okay, so hexadecimal, given an ASCII stream of hexadecimal or each one. Oh, 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 oh. Okay, so it's an ASCII string of S Zor. Oh wait, no. Okay, Zor string. Okay, so for I in range to yield is given an ASCII string of single byte hex, literals interpret as ASCII, return bytes decode. Given an ASCII string S of hexadecimal values or each one. Cooking MCs like a pound of bacon. Okay. Okay. So, yep, I definitely did something wrong. Can't reach that site. So let's see what solutions folks are doing here. So, let's just expand this. We're going to drag it out over. You can do this by hand. Okay. So from collections. So, okay. The approximate character frequency table of the English language. Table is, yeah, this is a byte. Englishness. Single byte Xor. Test string struct pack B byte. Length string. Single byte Xor. Given a string that has been encrypted by a single byte Xor cipher. Attempts to work out which byte was used to brute force testing every possible byte and testing the Englishness of the result. Englishness. Let's see how he does Englishness. Englishness. Total characters length A. What my old this recalls the fairly intuitive measure of overlap of two different distributions for each point in the distribution. Multiply the possibility for each distribution together. Okay, so sum all the possibilities together and get your coefficient. Simple. Okay, so use the Yeah, that's what I'm doing. So they're doing 0 to 256. So they're not doing hex characters. They're doing English characters. Okay. I see. We have a problem. So has been Zord against a single character, not a single hex character. So we need to do all of the 256 characters on the ASCII table, right? And look for the frequency of the most common characters, right? So we have some work to do. So that's a good stopping point for tonight. We've learned something. And I will do some, I'm probably going to work on this some over the weekend. And I'm going to do some rewriting to um, change it to using English. So I think the only difference I have to do is when I do my Xor break, instead of passing it a hex character here, right? Instead of doing the secret as a write pad of this and it being one of these hex characters, I have to do it over the entire 256 ASCII character set. So let's do a couple of things. So let's just do something. So if I do 1, 2, 255, right? And map over that. Map $ as binary as string. There is our. So we can throw away everything between. We can throw away everything that isn't tab, a new line. We can throw away everything that's not one of these, right? And so we want to keep 9, 10, 11. We would want to keep in line 9, 10, 11, FR, and these, right? Except we actually don't, because we only want to score. Oh no, because these could be, and it's a character, right? It's a character, not one of these. So we could start with 34, line 34 here, and go to 127 and score all of these, right? So we just throw away everything that isn't. You know what? Just as a sanity check? I kind of want to score. I mean, exclamation mark? Would that be. That's a valid. Like, why not? Yeah, so we'll just score. God, I kind of want to start on it now. All right, so here's what we're going to do. We're just going to do this in the data weave library for a minute. So we're going to do that. So here's our array, right? That's our array. Map. Matches. So that works. And it's going to be, ooh, actually, it's pretty good. We can just filter, right? Instead of map, filter. $ matches. So if I map that, what do I got here? So we got a bunch of trues, matches, and it's going to be, or filter, and it's going to be so regex ASCII printable characters. So is it that? Did I just learn something new about regular expressions? I did. I did learn something new about regular expressions. Interesting. Okay. 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 Awesome. Awesome. So then that becomes, so we hex encode these. These are candidates, right? We hex encode those. No, we don't even need to hex encode those, right? Uh, yeah, we do because we need to run the XOR function against them, right? So yeah, yeah. Am I still recording? I am still recording. Good. Okay. All right. So yeah, let's do this. Let's do this. I'm feeling like I got energy now. All right. So cool. I'm learning stuff. This is good. So we're no longer going to use hex characters. We don't even want hex characters anymore. We can, do we even need this function? Do we even need this? So if I delete this, it's only getting used. Is it getting used in any of these tests? No. Okay, good. So we're going to create a new var ASCII printable characters equals. And we're just going to steal this exactly as it is, right? Like that. Just do that. What is it? Auto coursing type from range to array. Okay, that's fine. That's fine. To, we'll just do as array. There, that makes things happy. And then this becomes ASCII printable characters. That is going to completely break our tests. Our tests are going to be all kinds of broken now, but this is going to work. This is going to work. This is going to be really interesting to see how it handles keys of pipes and other, and like double backslash. I'm going to see how that works. But so secret is size of hex string. Okay, so this can't work anymore. We need to convert these to ASCII, right? ASCII printable characters var hex characters equals ASCII printable characters, and then we're going to do map character, and this needs to be a um, this needs to be uh, from string to hex character. So we need this function. So, and we need it from binaries. Import from string to hex from binaries. Okay. And then this becomes hex characters, right? Hex characters. Reduce character ACC bum bum bum. Uh-huh. 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 And then score string hex to string hex string. Size of hex string, fixed XOR hex string and secret. Okay, that's gonna give us our fixed XOR. So Okay, so this is going to break our tests a lot. But it's good. It's good. I think we can get something useful out of this. So let's make sure we've saved all of our changes. File, save all. Okay. And Maven test. I'm gonna have a bunch of broken tests now. But I think we're like we're doing it. Okay. Okay. So so yeah, we expected the object to be size to be 16, but it was 95. Right. Right. Yes. Okay. Yes. Yes. This is now all kinds are wrong, but that's okay. We're gonna ignore that test for right now. We're gonna fix these. So so let's just get the let's change our tests, what we're testing here, to be something more manageable. So we'll break test. So this is no longer going to be our scores. We're going to say um, single character Xor entry for hello with AAAA scores dot scores A. Yeah. So okay. So let's do this. So var scores equals single character scores Xor entry, right? Um, and then we'll say that we're gonna find the we're gonna pluck the object. So I think we want to pluck this. So the reference. So we have an object and we want to convert it to an array. So that's gonna be we could do entry set. No, no. Core pluck. We have an object. We want to um, value key index, value key. So keys, values, indices, no. Um, what is the best way to do this? It's 9:41 at night. My my critical thinking skills are not keeping up with my excitement about solving this. So every entry behaves with different inputs. Every entry value is string. Okay, no. Set, key set, take while, value set. That returns an array of the values, right? So Filter object. This is what we want. Iterates a list of key value pairs on an object and applies an expression that returns a matching object, right? So filter object value. Can we do find over an object? Nope. Find over text, find over text. Oh, we could. Well, I am too tired to think critically enough to solve this. So we have objects divided by an object into sub-objects that contain the specified number of key value pairs. Nope. Uh, yeah, we can do this with value set, and we can. Okay, so let's import value set from objects. I don't like this, but we're going to do it. So import value set from DW core objects, right? And if we say the value set of this, right? Okay, we're even going to do this. So we're going to say top score bar top score equals um, top score equals scores. I'll do value set of scores. Oh, values of, excuse me, values of scores. So we don't need to import value set anymore because it's values of scores, order by negative, and take the first one, right? Okay. And then bar score highest score equal uh, so we do filter object. Just filter object on core. Yep. Highest score is gonna be scores filter object value key. We'll say we don't need. Let's just do value. Value equals top score. And that's going to give us back an object, highest scores. We can make that plural because it might be. And then now we just write our test and say highest scores must equal to a 7, something like that, right? And it's not going to be a, yeah, Might be A. Scores. And actually, this is interesting because it scores upper and lowercase, right? Yep, does upper and lowercase letters. So, that's actually fine, right? Fixed Xor. Is fixed Xor still? That might actually be a problem if we're changing the case, right? Fixed Xor. No, no, it's fine because this has to be a um, yeah, that has to be like that. So this can just go away. We're not using it at all, right? A should be the highest when hello is encoded with that hex character. So it may not be 7 anymore. Is it going to be 7? Oh, um, oh no, this is different now. So we're no longer encoding with A. We're encoding with the hex code of A. So var secret equals from string to hex. A? Sure, we'll just do A. This is no longer accurate. This needs to be secret, right? Pad secret with 2, 3, 4, 5, 5, right? Oh wait, what size is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So right pad, secret, 10 secret. We gotta import right pad. This test just got a lot more complicated. But we're gonna run it and see what we get. My watch is telling me it's time to stand up. My watch isn't wrong. I'm getting tired. I'm getting late. I'm getting a little punchy. It's okay. We're gonna get at least one of these tests passing, and then we're gonna call it a night. So we definitely gonna work on this more tomorrow. So did this test pass? It should score A to be the highest when hello is encoded with a hex character. It should score A to be the highest when hello is encoded with a hex character. Size of object is to be expected to be 1, but is 6. So let's log highest scores right here, right? Log scores. Let's see what we get. Yeah, let's do that. Hmm. Okay, interesting. 41, 48, 4C, 61, 68, and C. Right. These are hex characters, right? And we need to convert those to right. Why are those coming back as hex characters? So Xor break. So we are passing it a hex string. Candidates is upper split by this. Is that right? Should that be upper anymore? Or should it just be string split by? Yeah, it's fine because it's still a hex string, right? Okay. So 2 point letters, map, size of filter, character. Character needs to be hmm. 4C61. So what is the hex character for from hex 41? A. 48. H. C. It's L. K. 61. It's lowercase a. Interesting. What? Should score hex against a string. So what string did I give it that where it's scoring A and oh wait, hello, right? HELLO. We're giving it A, right? So is A one of the candidates that scored, right? It was, wasn't it? It's like 41 maybe? 41, yep. So it is the first one. So A, but it needs to be A, not 41, right? So we need to now filter. So here where we do our Xor break, we need to convert this score hex string, Xord hex string. Here we need to, so we have our pointers. So when we score hex string, we need, are scoring it. But when we score hex string, Xord hex string, character as binary as string. There we go. That's what we need right there. Yep. So now if we run this again, we're going to get a bunch of letters with the same score as that, which is fine, actually. If we look at what our letters are, that may be fine. Should include A. Yeah. So we just may not have a very, we may need to change like hello to hello world or something like that, right? So let's run our test again. We just may not have a word phrase that is I am That didn't work. Did I forget to save? Oh, did I forget to save? I did not change what printed out. So what printed out? Where am I printing here? So I'm logging at this highest scores, right? Filter objects. Single. So scores is single character. Source or entry. Right. So this should return an object of. So this is. This is what I thought was going to fix that. So character. So if I do. Oh no. It's this. It's from hex to string. Character. Right. There we go. So we're converting it to a string here. Yep. That was the issue. So, wow, it's already 10 o'clock. So let's try this. So we're gonna cut it off. If we get one passing test, we're gonna cut it off. Okay, good. All right. So these all, when encrypting hello, return 7. So let's do um let's do this. Let's change our test score A to be the highest when hello world. Hello. Let's just try that. Eventually we'll get one that makes it, like we'll get a complex enough. All right, so that got us closer. A, ooh, interesting. So why is it these two? I bet it's because I'm uppering in here, right? I shouldn't do that. Score, yeah, so it's actually fine though because is it fine? Do we care about casing? We don't. Wait, so let's do that. Okay, so is that still gonna work though? You know what? I'm fine with that for now. Let's 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 just do that for now. We'll figure it out later. Okay? We'll worry about casing later. For now, we're just looking for What happens if I take the upper off that? Is there a reason I did that? So just take the upper off there. And at that point, I don't need that at all. Just do string split by. So what happens? Does that break anything else? Well, it's going to screw up my scoring, right? Mm-hmm. Interesting. So A becomes right. So interesting. So why is it? So I'm not uppering it. Am I doing? What am I doing here to make that be a lowercase a? So hello a. Here we go. Right pad. So from string to hex a. Uh-huh. My secret. And then we're right padding that. Fix Xor hello world. Okay. Actually liked it better when it was uppering it because yeah, that's a bug. I don't know why it's a bug, but it's a bug. We're gonna fix it another day though, because it is too late to fix it now. So we're just gonna save that. We're in a really good situation. I think we're like so close to getting the right answer now. Okay. All right. We're going to stop it stream there and we'll come back probably tomorrow to work on this some more. And we are going to find the correct answer for the encrypted letter or the letter that was used to encrypt. So from hex 41, if I do 2 hex A, A. So 61 and 41. Interesting. Hmm. We'll have to figure out why that's doing it that way. But in the meantime, let's call it a night.